there are subtleties even to things that appear as simple as addition. Here I've got some addition problems. 4279 plus 1202, 4277 plus 1190, 4269 plus 1207, 4273 plus 1191, and 4270 plus 1200. You'll notice that they're all close to this problem. The numbers that I've been listing off are all hovering around this problem. Anyway, I'm going to give out these problems to some people, have them try to do them.
Hi, I'm Eaton Patel, and I'm a math TA here, undergraduate at Ohio State.
Yeah, my name's Jacob Turner. I'm a graduate TA here at OSU.
All right, people have finished doing their arithmetic problems. Let's record their answers. So here, 4270 plus 1200 was 5470. 4279 plus 1202 was 5481. The next one is 5476. I've got 5467. And the last one was 5464. What do all these numbers have in common? They're all really close together. Is that just an accident? Of course, it's not an accident. Right? Here's the fact. Near the sum of two numbers is the sum of two nearby numbers. These arithmetic problems are not just random arithmetic problems. Look at the numbers I'm asking them to add. 4277 and 1190. Those numbers are really close to 4273 and 1191, which is really close to 4270 and 1200, which is really close to 4269 and 1207. Right? Near the sum of two numbers is the sum of two nearby numbers. All of the answers are nearby as well. How does this relate to limits? Let's take a look. Here's how it relates to limits. The limit of f of x plus g of x as x approaches a is the limit of f of x as x approaches a plus the limit of g of x as x approaches a. How is this related to those arithmetic problems? Well, remember what this limit is saying. This is saying, what can I make f of x plus g of x close to if I'm willing to make x sufficiently close to a? Well, it's going to be close to whatever I can make f of x close to, added to whatever I can make g of x close to. Right? It's the same kind of setup. Right? Near the sum of two values is the sum of the nearby values. So the limit of a sum is the sum of the limits. We can use this fact to do some calculations. Let's see how. So here's a limit problem. The limit of x squared plus x as x approaches 2. I really want you to resist the temptation to just plug in 2. We're going to be using our limit laws to try to evaluate this limit. Now this is the limit of a sum. And the limit of the sum is the sum of the limits provided the limits exist. So this limit of x squared plus x is equal to the limit of x squared as x approaches 2 plus the limit of x as x approaches 2. Now, what's the limit of x squared? Right? Because the limit of the product is also the product of the limits provided the limits exist, this is the limit of a product. This is the limit of x times x. That's what x squared means. It's x times x. So I could rewrite this as the limit of x times x as x approaches 2 plus, now what's the limit of x as x approaches 2? This is asking, what does x get close to when x gets close to 2? Or said more precisely, what can I guarantee that x is close to if I'm willing to make x sufficiently close to 2? The limit of x as x approaches 2 is 2. Right? So this limit is just 2. Now this is the limit of a product. And the limit of a product is the product of the limits provided the limits exist. So this limit is the limit of x as x approaches 2 times the limit of x as x approaches 2 plus 2. Now again, the limit of x as x approaches 2, right? What can I guarantee that x is close to if x is close to 2? Well, 2. So this is just 2. This limit is the same thing. It's again just 2. And here I plus 2. 2 times 2 plus 2 is 6, which is the value of the limit of x squared plus x as x approaches 2. The takeaway message here is, ask not what your country can do for you, but what you can do for your country. Or, in other words, that the limit of a sum is the sum of the limits, provided the limits exist. It's the same rhetorical device, right? X, y, y, x. Right? The limit of a sum is the sum of the limits, provided the limits exist. I hope this is very memorable, because these kinds of chiastic rules are going to be used throughout our time together in order to evaluate limits. Soon, we're going to see that the same sort of pattern holds not just for sums, but for differences, for products, and almost for quotients. Good luck.